As you know, my name is Kyneton the Genius, and I'm really happy I found a way to break down data science and machine learning into very small bits so that everyone can actually understand what is happening. I've created a full lesson, which is a practical lesson where we are going to analyze data sets and actually understand the concepts of data science and machine learning. Precisely, we are going to be covering classification. So classification is part of supervised learning, which is the core of data science, machine learning, robotics, and all these other automated systems. The core is classification. And it simply means being able to see something and classify it correctly. So a self-driving car should be able to see a tree and classify it as a tree, see another car and classify it as a car, see a truck and classify it as a truck. So classification is the core of data science, and if you learn about classification, you are actually good to go. You learn the basics, or more like the basic to the advanced. And in this class, I'm going to be taking you from the basics, and we are going to be covering some key concepts so that after now, if you want to read a textbook or if you want to take another course, that will be very easy. But after now, you should be able to analyze the data set, because that's what we are going to be doing step by step. And the data set we are going to be using is the iris dataset. The iris dataset is a very famous dataset that is used for machine learning. So it's a CSV file. So I'm going to show you how to import it into Python. We are going to see this dataset, do a bit of data cleaning, which is what we are going to be doing here. Split it into the features and the classes, and also split into train and test dataset. I'm going to be explaining this concept as I go. We are going to build one classifier called decision tree classifier and see how the performance is, like the accuracy of this classifier. And then we also build another classifier to compare the performance of these two classifiers. And then we are going to look at the confusion matrix. Now, this is very important for you to understand this concept of confusion matrix. That's why I've made a different video, a different presentation. I'm going to be explaining confusion matrix more in depth right in this presentation, and we are going to calculate for this data we are working with now. We are going to use what we learned to calculate the accuracy, the precision, and true positive rate, false positive rate, and a few other things I'm going to tell you that you are going to delve into after now. So please subscribe to my channel, and also if you have any challenge, let me know, because this is a way I want it to be very easy for everyone to be able to learn something that ordinarily would have been very difficult to learn. That is exactly what I'm doing right here. So please try to follow as much as you can. If you have challenges, please let me know. And also, one thing I would like to mention is classification as part of data science and machine learning is very important in real life, even for common people, for ordinary people like you and me. For instance, you have COVID tests. Do you know that some of the tests performed returns a wrong result? So what it means is possible that someone does not have COVID and he's classified as having COVID. It's also possible that someone has COVID and he's classified as not having COVID. This is called type 2 error. And if type 2 error happens, it may lead to death. And that is why, if you look at this place, you see in the case of this part here, you have very bad, we call it a false negative. In this case, very good is true positive, and so on. So we are going to be covering this and see how it applies in the Python code we are going to be writing. And there's a confusion matrix for 2 by 2. We are going to be looking at the iris data set containing 3 classes. We're going to be looking at 3 class confusion matrix and be able to explain this concept of accuracy, precision, and recall. So please stick with me and let's start right from the scratch. If you are a beginner data scientist, simply install Anaconda. That is all you need to follow this class. So let's dive right in. At this point, I'm going to take out this notebook away so that we are going to be starting a new notebook. So the first thing you are going to do, you need to download the iris dataset. So basically, if you go to Google, or you can check the description box of this video, I'll put it right there in the description box of this video. So you don't have to worry about going to Google Another thing you can just read up just to understand what is happening in case of classification and decision making. Simply enter decision theory, Kyneton, and you see where I explained the basics of decision theory, and you see this famous, this very famous image that is always recurrent. And please try to read up a bit, because if you have a bit of theoretical knowledge, it helps you understand the practical as well. So let's do this together. So the first thing I want to do is for us to open a new notebook. So I'm going to say new, Python 3. I'm going to start a new notebook. Now I can actually be annotating the code. So what it means is that I can be adding a comment to explain the following code. For instance, I can say import NumPy and pandas. These are simply tools that helps you perform bits of calculations. All right, so import pandas and NumPy. As here I've mentioned, pandas is used for handling data sets, like handling tabular data. NumPy is used for a bit arithmetic. Import pandas as PD. Import NumPy as NP. Okay. So the names as is simply making it a bit shorter. You can actually use it the way it is without using as. So in that case, you will be saying NumPy, but in this case, we've made the name short, like an alias. I also like to mention that in this class, I might be copy some codes, code base I have, and paste it just to save time, so that we go a bit quicker. All right. So in this case, I'm going to rename this file from untitled to data science practical class. Okay, so this is what I have here, and now I've created one cell. Now in Jupyter Notebook is in cells, so I have one cell now. If you click on this run icon here, it's going to run it and shift advance to another cell so that you can type what you want to type. In this case, it's better to enter in different cells so that when you have an error, you know which cell actually contains this error. But if you enter everything in one cell, when you have an error, it becomes a bit difficult to troubleshoot. So in the case of the data set, I'm going to also import my data set. Now, if you want to add a comment, you use the hash key to start the line. So I'm going to say import the iris data set. And this is the iris data set is in my computer. So I'm going to import it and assign it to a variable called df. So I'm going to say pd.read underscore CSV. So this is how to import a data set. You specify the path to this data set and specify the separation to be, I think it's a comma separated variable. So I'm going to just put the separation to be comma. And I'm going to say engine equal to Python. All right, so at this point, I'm going to now go to where I have the data set in my system and then copy the path to this data set. So let me just look for this data set in my system. I think I should have it in, let me see, documents maybe. Let me see, let me just go to home, data sets, and I should have the iris.csv, which is this one. So I'm going to right click and say, hold down my option key and say copy iris.csv as path name. So I'm going to click, and then I'm going to go back to my notebook and paste it right here. Yeah, if the font is too small, please let me just increase the size of the text, and I hope it should be better at this point. So now we've imported this data set, but we've not actually run the cell. So I'm going to just click run. Now to check whether it's imported, I'm going to say df. If I say df, it tells us what was imported. df.head. I think df.head maybe gives us the first items, the first 5 rows, and df.tail gives us the last 5 rows. So now we have to understand this data set a bit, because if you're working on data, if you're a data scientist, the first thing you do is to understand your data set. Now you have the sepal width, sepal length, petal width, petal length. These are the features. And with these features, we want to determine the name, which is iris setosa, versicolor, or virginica, because I know about this data set. So if I go to maybe enter df.head100, you can see we have versicolor here, and I have another, let's say, df.tail. And now we have virginica, you can see. So there are three classes. So it's a multi-classification problem. So it's not two class problem, but three class problem, which is very important. Which is more like going a bit from basic to intermediate data. So now we have our data set. The next thing we want to find about our data set is how many items are in this data set. So I'm going to say len df is going to tell us how much data is available here. It tells us 150 rows, and the number of columns you can see. But if you want to be dead sure about the number of columns, I think you can say df.info, and it tells you, gives you more about this data set, and you can see everything about this data set. So there are a few other things about data engineering or data information checking I'm not going to cover here. Now, classification in Python requires that the classes have to be numerical. What this means is either 0, 1, 2, or 0 and 1, or 0, 1, 2, 3, so it has to be numerical. But what we have here is a text data, right? Categorical data. Yeah. So we have to find a way to convert this three classes, virginica, versicolor, and setosa, to 1, 0, 1, 2. And to do that, you simply say df, you specify the name of the column you want to convert to categorical, to numeric, and simply say pd dot categorical, and specify the name of the column. Okay, so this is the first step. So I'm going to run to make sure it works. So it works. So I'm going to take the next step says here name. Now I'm going to change it to numbers. So df name dot cards dot codes. So it's going to return the codes, which is 0, 1, 2, if I'm not mistaken. So what we did now is actually data cleaning, which is a very wide topic. I covered it somewhere else, but we can't go far because I want this class to be very easy and clear. All right, so let's assign x and y, because now we have x1, x2, x3, x4, and y. So basically, I'm going to just show you what we want to do. So we want to say a function of x, function of x1, x2, x3, and x4, y is equal to, because in this case we have only one y, only one y column and 4 x column. We can also say y is equal to f of x, where x is equal to x1, x2, x3, and x4. So the different ways to represent it. So in this case, permit me to just comment this line out, and I'm going to want to assign like this. So I'm going to just say y is equal to x, right? Okay, but in this case, x is a vector of 4 different items. All right, so to do that, I'm simply going to say x is equal to df dot values. Now pay attention that we want to select the first four columns we want to select, and all the rows, or all the rows and the first 4 columns. How do I do that? You specify all the rows. You can just say leave it empty and say comma. So I'm going to explain to you all the rows and column 0 to 4 like this. 0 to 4. So at this side where you have before the column, we have something like row 0 to row 150. All right, and we specified column 0 to 4. Yeah, so that's exactly. But if you omit these values here, like you omit 150 and omit 0, then it's going to take everything, like all the rows. So it depends on how you want to do it. So let's just be clear about this. I'm going to say 150. And in this case, y, in this case, you can guess it at this point. Y is equal to all the rows and column 4. So df.values, all the rows. So you can specify just empty like this, and column 4. In this case, I'm not specifying a column range, one single column. You can just specify it as column 4. When you use a column separating two variables, it's going to go from the first variable to the second variable minus 1. So if you specify 0 column 4, it's going to take 0, 1, 2, 3. 0, 1, 2, 3. That's the indices of these columns. Make no mistake about this. It's not going to take 4. It's going to take 0, 1, 2, 3. But if you specify 4, is now going to take only that very column specified. So if I run this code, it's fine. Okay. So if you look at X now, you can see that it gives you the array of values. But I'm not going to mess up my notebook. So let me just take out this. All right. So when we are talking about classification, there is something you need to know. Classification is a subset of supervised learning. Supervised learning means you have to have two data sets. The first data set is the data set you use to train your model, and the second data set is the data set you want to use to test the model. What does it mean? If you want a dog, this canine dog that used to detect drugs in the airport, these police dogs, the first thing they do is to train them with drugs. Yeah, you put all these drugs or cocaine or whatever, and tell them to sniff on it, and they get used to it. When they detect it in this one you are using to train them, it's not the real actual drugs. And later, you are going to now test them. Okay, you put different items. This is cocaine. This is other things, and you're going to test it to check whether it's going to detect it. So the point I'm making is, when we are talking about classification, the first thing we want to do is to train our data set and test our data set, and then move it into production to actually work. So the guard dog or this canine dog have to be trained, tested, and now taken to the real airport to actually do the work. So there are 3 steps. So the first thing we want to do is to split this data set. The first data set will be 70% of this data we want to use for training, and 30% of this data we want to use for testing. So how do we split these 150 records into testing and train data set? So we are going to use another library another module called skline. So first, let me put a comment, split the data set. Now this is what is going to happen. So I'm going to say from skline. Now there are many modules out there, so you are not going to get used to all of them. Gradually, you're going to be using them. So in this case, know that skline is used for training, model training, and for splitting data set and other things. skline.model selection, skline.model selection, import, train, test, split, and now we are going to, we are splitting into 2 data sets. So let me just see if I can just show you what is happening. Let me go to my whiteboard. I think I have a whiteboard somewhere. Yeah, I have a whiteboard right here. So basically, we want to have we have x and y. Right now we have x and y. So we want to have x train, and we'll also have y train, and we'll have x test and y test. So from this x and y, we want to get these 4 different sets. Okay, so let's go back to our notebook. Let me go back to my notebook. So to do that, I'm going to say x train, x test, and y train, y test equals train test split, because this train test split is a function we imported from sklearn. So you specify the data set you want to split, so it's going to be x, y. I want to specify the test size. What percentage of data do you want to use for testing? So it's going to be 30% of the test, 30% of this data I want to use. Like the test size is going to be, sorry, I don't know what's happening here. Text size is equal to is going to be 0.3, and random state equals 0. So at this point we've split our data set into test and train data set. So if you want, you can actually check what is there by saying x train. You can just say the length of the x test. So I think it should be 45, like 30% of 150 should be 45, I think. So let's see. Yeah, 45, you can see from here. All right, let's now build the classifier. So what's classifier? Classifier is simply something like the function, yeah? The function that relates to x and y. We don't know this function because we say y is equal to what the function of x and y. Is it x1 x squared plus 2x plus 2x plus x2 or something? We don't know this function. So this classifier is a black box that contains this function, so that if you give it x, it's going to spit out y for you. So this black box, this function, is what we call the model. All right, so there are different classifiers. They have different performance and works with different data. So in this case, let's build a decision tree classifier. So I'm going to say, put a comment, decision tree classifier. All right, so we are building a decision tree classifier, and the model for building a decision tree classifier is also from sklearn. We get it from sklearn. From sklearn import tree. So how does decision tree classifier work? It simply splits the data into 2 at each time. It keeps splitting the data into 2 and selecting subsets of this data until it has only leaf nodes. I think it's not something I can explain at this point because it requires actually giving much illustration. But for now, just know that a decision tree classifier is used to perform classification. I think that's the most simple classification classifier that you can work with. What I want you to do, take notes, just follow this lesson and make sure that you don't have any errors until you get to the end, and let me know in a comment, and then I can take you on to the next part of this data science class. That will help me evaluate how you are doing or how much you understand what we are doing. So I'm going to call this decision tree classifier dt clf equal to tree, which is the tree I imported, dot decision tree classifier, decision tree classifier max depth. Of course, you know what the tree depth of a tree is, which is if you are splitting a tree from the root nodes, how much depth does it have? Max depth is equal to 5, and we now give this decision tree, this model is an empty model now. We have to now train it using our training data set. So I'm going to say dt clf dot fit. So what we are doing now is to train the model. So I'm going to give it the training data set and y train. Okay. So yeah. Okay. So I'm going to run. Hopefully it works well. Okay, perfect. So it gives us all this. It's actually performed the training. So there is a complex process that happens actually inside the decision tree algorithm. We cannot so much talk about for now. So we are now going to try to make a prediction. Now, giving it the test data set to test how it performs, we have to give it some test data. Okay, predict. Take this test data set and predict, and let's see how it performs. And then we know the score. How much did it get right? How much did it get wrong? That will help us calculate the accuracy of our classifier. So I'm going to say DT, the decision tree classifier. So what we are doing now is to test. So in this case, we are now going to give it the test data set using .score, and see how much it will score using the test data set. All right, so we are testing it now, and it scores 97%. Impressive, but I'm going to explain a little more. Now we have we've tested it and it's fine, but you can also make predictions. So in this case, you are given it only the X data and you want it to calculate the Y. So to do that, say Y predict. You want it to calculate the Y now, giving it only the X is equal to DT the TCLF.predict X test, and you can now score it one more time. So DT CLF.score. Okay, I think this is what we already did. So what you can do in your own time, you can just display the Y predicted and the Y test to check how they relate. So basically what I'm saying is that you can check Y pred like this and check how it relates with Y test and see which ones it got wrong and which one it got right, okay? And finally, this is very important because that's going to now take us to this calculation we are going to do by hand and see how it relates about the confusion matrix and about true positive rate, false positive rate, prediction, accuracy, precision, and other things. And type 1 and type 2 errors. So I'm going to say from sklearn dot metrics. Now we are talking about confusion matrix. Import confusion matrix. All right. So confusion matrix. So we want to display confusion matrix. We want to display it to the output. Y test and Y pred. Okay, so now we are displaying it to know which one it got right and which one it got wrong. And I'm going to run. No module named sklearn, so it's sklearn, not sklean. So I'm going to run. Now this is where it gets interesting. Now we have our confusion matrix. There is also another classifier I built called random forest, but to save time, let's now talk about the confusion matrix because that will help you understand exactly how classifiers work. So I'm going to go exactly to my presentation right here. A confusion matrix is a table that is often used to describe the performance of a classifier model on a set of test data for which true values are known. So you have to know how confusion matrix works. Normally, it's a square table. Now, this is an example, okay? So let me explain to you exactly what's happening here. So a confusion matrix, this is an example, a sample confusion matrix, and this is explaining what is happening. So what it means is that we have 50, 10, 500. Now the actual values, now there are two classes here, no and yes. This is the actual and this is predicted, and there are 165 samples tested. This cell here means that the actual value is no and the predicted value is no, so it's correct. That's what this cell means. This cell means that the actual value is yes, but 10 were predicted as no. Let's understand it very clearly. The first one, there are 50 predicted, 50 actual values that are no, and that 50 also were predicted as no correctly. Okay, 50 no, it was predicted correctly. In the second column, we have actual no values, which the classifier predicted as yes. So this is an error that has occurred here. In this case, we have an actual yes and no was predicted, 5 no were predicted, when actually the values were yes. That's what we have here. And in this case, there are actually hundreds values that are yes, and it was predicted as yes as well. Now, how does this relate to true positive, false positive, and so on? Now, in this case, we are talking about no and yes to be positive and negative. So let's see. But now this table will be confusing when you use it, you use it with this one, because actually this should have been negative. This should have been positive. However, this one means that if you have a 1 and it's predicted as a 1, it means that it's a true positive. It's a 1, it's predicted as 1. 1 is the person has COVID and is predicted as COVID is 1, right? It's true positive. It's a positive COVID test and it's predicted as true. This second one is a positive COVID patient, but the test or the model predicted it as negative. So it's a false negative, and that's very bad. That is type 2 error. It has to be avoided at all costs, this type 2 error. Now this cell here means that the person has no COVID and is, let's see, no COVID and is predicted as having positive, as having COVID. So it's a false positive. So the test came out positive, but it was not true. It was not correct. It's a problem, but it's actually not a big problem. It doesn't lead to death. You simply you'll be treating somebody who is actually not sick. But yeah, I mean, you waste resources and money and time, but at least nothing actually very bad happens. Then in the case of the last one, the true negative, the person has no COVID and is predicted correctly. So what you can see at this point is that this the diagonal values going from top left downwards are actually true values. They are correct predictions. So this is true positive, is positive and is predicted correctly. This is negative, is predicted correctly. Off diagonal values, they are wrong predictions or the errors. So below we have type 1 error and above we have type 2 error. So as much as possible, we want to avoid type 2 error. So if we go back to our the displays, we can see that we have an error here, which is a type, more or less like a type 2 error, which is a very not so good. Okay, so let's see. Yeah, so this is what I was explaining about cancer treatment, and I think you understand it by now. Now, when we have more than one class, like we have 3 classes, we can now calculate the false negative, the true positive, the false positive, and the true negative. Now, here is the thing. This table always goes like this. We have true positive, false negative. We have true negative, this is false positive and false. This is true positive, false negative, false positive, and true negative. So So the only way to understand it clearly, let's just go. Let me just show you. I think I told you already before. You can just go to my my website, KinetonTheGenius.com, or just type decision theory Kineton. It takes you to where we explain these decision theories. You have my presentations. You can actually review it if you want. All right, let's now go back to confusion matrix. Now, the false negative is the total number of false negatives for a class. Is the sum of the values of the corresponding row, excluding the true positive. So let's just see how it plays out. Let me move this to this place. So let's go to this place. So in our confusion matrix here, we have the true positive for the first class, which is iris setosa, is 16 plus 0 plus 0 minus the true positive is, of course, true positive is a diagonal value, but true positive for the iris setosa class, the class 1, is 16 plus 0 plus 0 minus 0 plus 0. So that's why it says the I think I'm mixing it up, so forgive me for this. The true positive is already there in the diagonal, so it's not calculated. It's already determined and written there. But the false negative is the number of false negative, the sum of the values in the corresponding row. Yeah, so let's see. So the false negative for the first class is the sum of the values for the row, 16 plus 0 plus 0, minus 16. So in this case, in the first class, there is no false negative. And the same thing, in the second class, the false negative is 0 plus 17 plus 1, which is 18, minus 17, which is 1. So we have one false negative. Let's just get it right. One false negative in class 2. And in the third class, we have 0 plus 0 plus 11 minus 11. We don't have any false negative. So you can figure this out. This presentation you can find in the description box below this video. Because I don't have much time, I want this to end. I would like you to read this up, and then we are going to go a bit advanced into classification. After now, this is basically true positive rate, because there are things you need to know, like accuracy. Is the sum of all the correct classifications divided by the number of classifications. This is very important, so I'm going to just talk about it a little bit. So if we go back to our classifier, we have the total number predicted is 150, and the total number of correct prediction is 16 plus 17 plus 11, which gives you total 16 plus 17 plus 11. That gives you 45, I think. Let's see, because we have the accuracy is 16 plus 17 plus 11. 16 plus 17, that's 33, plus 11, 30, 44, 45 was predicted, and 1 was predicted wrongly. So we have 44 over 45. Let's see. Just let me just use my 44 over 45. Yeah. So 44 correct predictions over 44 correct, 1 wrong. So 44 over 45 giving us 97%. And this is 97% you have right here, which is the accuracy we calculated. I don't want to go too far. I want you to just take your time to work out this yourself using the information I already provided in this presentation. So I'm going to stop here. I want this to be just a simple class, not too advanced. For everyone that is smart, you don't have to be a scientist to follow these classes. That is what I want to do, to break it down, so anybody that wants can actually follow it easily. So just let me know what you think. Is this a good way of doing it? Do you want something really more advanced, or do you want me to take it a bit slower? So let me know in the comment box below. I'm going to be stopping here, and I'm going to be continuing in the next class. I remain Kineton the Genius, and I'm always there for you.